Hi, in this video, we are going to continue the theory of circles and we start off by talking about the chord of contact. So as we have discussed before for conic sections, the chord of contact is the chord joining the points of tangency P and Q if from some external point you have drawn two tangents to the circle. So basically, let's say this point is R, H, K. The chord PQ is the chord of contact, right? And we want to find the equation of this chord. Here, RQ and RP are tangents to the circle. So RQ is tangent to the circle and RP is tangent to the circle, right? So if you have a situation like that, the equation of the chord of contact becomes basically the tangent equation T is equal to 0 with respect to the point R, H, K. So if my circle was x square plus y square plus 2gx plus 2fy plus c equals 0, the equation of chord of contact is simply write the tangent equation but pretend it is from point h, k. So it will be xh plus yk plus gx plus h plus fy plus k plus c equals 0. So this theory has been discussed before, even for other conic sections. The theory is exactly similar. The chord of contact is basically T is equal to 0 with an external point h, k, right? Okay. Now, the next thing is basically the equation of chord with a given midpoint. With a given midpoint. And the midpoint is given to you. That point is, let's say, x1, y1. So in this case, if the circle equation is s is equal to 0, which is x square plus y square plus 2gx plus 2fy plus c equals 0, the equation of the chord with a given midpoint P is basically T is equal to S1, where both T and S1 are written with respect to this point x1, y1. So what will be the T equation? It will be x1 plus y1 plus gx plus x1 plus fy plus y1 plus c. And what is S1? S1 is putting x1, y1 into the circle equation. So it will be x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. So t is equal to S1 becomes x1 plus 5y1 plus gx plus x1 plus fy plus y1 equals x1 square plus y1 square plus 2gx1 plus 2fy1, and the c gets cancelled from both sides. And this equation is the equation of a chord with a given midpoint, right? Okay. Now, another version of this that you should know is this version. It says if the line Lx plus my plus n equal to 0 cuts the circle x square plus y square equals a square in A and B, in 2 points A and B. So basically the line is a chord of the circle. Then midpoint of AB is basically this point. We can find this point like this: minus ln by L square plus m square and comma minus mn by L square plus m square. Now, I don't want you to try to remember this. What you should do is know the method by which we get it. So here, imagine this is a circle. The circle has center 0, 0 and radius a. And let's say this is my line and this is my point A and point B, right? The midpoint is somewhere here. We want to find this midpoint. So if the point here P, the midpoint is x1, y1, then equation of chord with midpoint P with midpoint P can be written as T is equal to S1, right? You can write it as T is equal to S1 equation, and you can compare with the line Lx plus My plus N equals 0 and compare the coefficients and get the coordinates of x1, y1, right? Another way you can think of it is, you know that P is the foot of perpendicular from center of the circle C to the line AB, right? Because we know that perpendicular from the center bisects any chord, right? So drop a perpendicular from the center to the line AB, and that foot of the perpendicular should be the point P, right? So you can do that by straight lines theory. The center is 0, comma 0, and the line equation is Lx plus My plus N equals 0. So the foot of the perpendicular will come by doing x minus 0. So we can write it like this: x minus 0 is from 0, 0. So we have x1 minus 0 by L is equal to y1 minus 0 by M is equal to minus of L times 0 plus M times 0 plus N by A square plus B square, which is L square plus M square, right? So that is coming out to be minus L by L square plus M square. And x1 is coming out to be minus NL by L square plus M square. And y1 is coming out to be minus NM by L square plus M square. So that is a faster way to get the foot of the perpendicular. And from there, we can figure out the midpoint of the chord, right? The next item is pair of tangents drawn from an external point, P x1 comma y1 to a circle S equals 0. And the way to write this equation is S1 is equal to T square. So here suppose S equation is x square plus y square is equal to a square. And the point is x1, y1. So your equation would be S would be x square plus y square minus a square. S1 would be x1 square plus y1 square minus a square. Putting the point in the circle equation, you get S1 here is equal to T square. So tangent equation would be x1 plus y1 minus a square whole square. So this combined equation is the equation of the pair of tangents from the external point to the circle, right? Okay. Next thing that we want to talk about is the idea of common tangents. Common tangents to two circles, and the two circles are given by S is equal to 0 and S dash is equal to 0. These are the equations of the two circles. So how do we find common tangents? So first of all, you have to understand there are two types of common tangents. There is a direct common tangent and there is a transverse common tangent. So direct common tangents are common tangents which are on the same side. So for example, there is a circle like this and a circle like this. This is known as a direct common tangent. This line L is tangent to both the circles but on the same side. Similarly, this is a direct common tangent, right? And a transverse common tangent would be a tangent like this, where you have a tangent line like this, which is tangent to the circle on two opposite sides, right? These are transverse common tangents. So first of all, we want to understand how many possible tangents are there. So you have multiple cases. How many possible common tangents are there? So if the two circles are far away such that the distance between their centers C1, C2 is greater than R1 plus R2, then obviously you will have two direct tangents and you can also have two transverse tangents, right? So if C1, C2 is greater than the sum of the radii, the two circles are far away, you will have four common tangents. The next case would be if C1, C2 is equal to R1 plus R2. In this case, the circles are touching each other. And in this case, there is only one tangent like this common and two direct tangents. So in this case, there are three common tangents, right? If C1, C2 is equal to R1 plus R2, there are three common tangents. If the circles are intersecting, then there cannot be transverse tangents. It will only have two direct tangents, direct common tangents. And this happens if the distance C1, C2 is less than R1 plus R2, right? The next case is when one circle is internally touching another circle, in which case you cannot have direct tangents. There is only one tangent is possible, one common tangent, right? And this situation arises when the distance between the centers is equal to the modulus of R1 minus R2 or is equal to the difference of their radii. C1, C2 here is equal to the difference of their radii. You get only one common tangent here. And finally, there is the last case when one circle is completely inside the other and you get zero common tangents here. And this happens if C1, C2 is less than mod of R1 minus R2. So the one circle is completely inside the other circle and you get only one common tangent in this case, right? Now, how do we find the equation of direct common tangents or transverse common tangents? So that is an important idea that you need to understand properly. The detailed discussion of this is in SL Loney, and I would recommend everyone to go through that section in SL Loney. I will describe what to do here. So I want to find out the equation of the direct common tangent, right? So let's say I want this direct common tangent, right? We can also find the other one, okay? So let's say this is C1, this is C2, these are the centers, and this is the radius R1. And notice I am drawing radius from center to the point of tangency. Let's call it A. Let's call this point B. And this is another radius. We know that this line C1A will be perpendicular to the common tangent. Common tangent is L. And similarly, C2B will be perpendicular to L. So obviously that implies C1A is parallel to C2B, right? So these two lines are parallel because they are perpendicular to the same line. Now what I have drawn here is I have drawn the line joining the centers and I have extended it, and I am extending it so much that it meets this line L, which was the common tangent at a point, let's call it D, right? So this D is the point of intersection of the common tangent L, and the line C1, C2, which joins the two centers. Now, if I want to find equation of line L, that is my target. Equation of common tangent. That's what I want to find out, right? The first step is always finding the coordinates of this point D. So how can you find the coordinates of point D? So notice first of all that the circle equations are given. So what information do you already know? We already know C1, C2, R1, R2. Basically, we know the location of the centers and we know the radius of the circles, right? And you can easily see here that triangle DBC2 is similar to triangle DAC1. Why is it similar? Because one angle is common. The angle BDC2 is same as ADC1 and the other angle is 90 degree here. There is 90 degree here. So it's a right angle triangle and these two triangles are similar. Therefore, the ratio of the radius R1 and R2 is also the ratio of DC2 and DC1, right? We can say DC2 by DC1 is equal to R2 by R1. And basically, now I know this much is R2, then this much is R1. So we know the ratio in which the point C2 divides the segment joining C1 and D. So we know C2 divides C1D in the ratio of R1 minus R2 is to R2, right? So now that we know the ratio in which C2 divides C1 and D, by section formula, we can find the coordinate of D, right? Section formula will easily give us the coordinate of D. 1 second, just hold on for a moment. Right. So because I know the location of C1, x1, y1, and location of C2, x2, y2, I can find the coordinate of D. What I will do is section formula. I will say the ratio is R1 minus R2 is to R2. So I will say R1 minus R2, let's call D as x comma y, multiplied by x plus R2 times x1 by the sum of the things is R1 minus R2 plus R2, which is R1, should be equal to x2. So notice this equation gives us the value of x because everything is known here. x1 is known, x2 is known, R1 and R2 are known. So this equation gives us the location of x. Similarly, I can do the same section formula and get the y coordinate also. So the first job is finding D. And if you do it by similar triangles and section formula, you can easily find D. After that, the problem is really easy. You need to make a line passing through D, which is tangent to any of these circles, right? So what I will do is, let's say I found D point and D point was x naught, y naught, right? So I will say the equation of my line through D is y minus y naught is equal to m times x minus x naught. And this line is tangent to any of the circles S1, S2, right? So let's say circle 1 equation was x square plus y square is equal to a1 square, right? So what is the condition that this line will be tangent to this circle? I can say perpendicular from 0, comma 0, which is center of this circle, to this line, to line y minus y naught is equal to m times x minus x naught, will have length equal to the radius of the circle equals to a1, right? So I will drop a perpendicular from 0, 0. It will be minus y naught minus m times minus x naught mod root over 1 plus m square should be equal to a1. And because I now know y naught and x naught, this is an equation involving only one variable m. I also know a1, so therefore I can find m from here. And once you find m, you know the equation of the direct common tangent. So remember the process here. Finding the equation of direct common tangent means drawing this line, the tangent line, joining the centers, finding this point D. C1, C2, find the point D first. How do I find the point D? By similar triangles and ratios. The ratio will be R1 is to R2. So this distance is some R1 and this whole distance is, I'm making a mistake. This distance was some R2 and this whole distance is also R1. So that is the ratio in which the point D divides the segment C1, C2. If you find D, write an equation of line through D. Y minus YD is equal to m times x minus xd. And write the condition that this line is tangent to any of these two circles. Is tangent to any of these two circles. If you write the condition correctly, you will be able to find the slope, and that will give you the equation of the direct common tangent, right? So this process you should understand. Don't try to remember any formulas here because it won't work in the exam. For transverse common tangent, we follow the same process. The situation is absolutely similar. The tangent is now like this, right? So I'll draw a better tangent. It's like this. This is my tangent now. This is C1, this is C2. The point is inside now. That is the only difference. This line is perpendicular R1. This line is perpendicular and this is R2. And again, we can say that this triangle and this triangle have vertically opposite angles and they will be similar. So your job is simple. You have to say that this distance is going to be proportional to this distance in the ratio of R1 is to R2. Therefore, you have to find D again. Find D by section formula. By similar triangles, you'll get it by section formula. Once you find D, write an equation of line through D, right? And put the condition that this line is tangent to any of the circles. That will give you the value of the slope. Once you find the slope, you have the equation of the transverse common tangent. So this process you should understand. Don't try to remember everything here, right? The next topic that we have to talk about is angle between two intersecting circles. Angle between two intersecting circles. Okay. So for angle between two circles, conceptually you need to understand, let's say this is circle 1 and circle 2. The circles are intersecting, let's call it S1 and S2. S1 and S2. The circles have center C1 and center C2. And let's say this is the point of intersection. This is the point P that we are talking about. We want to find out the angle between two intersecting circles. So angle is actually the angle between the tangents. What it means is angle between the tangents to both the circles at the common point. So tangent to this circle here, this is the line L, which is tangent to C2. L is tangent to S2. And similarly, you can draw a line M. Actually, this line will pass through C2, right? And C1 will also pass through C. Okay, I will just draw it properly. Okay, it's not necessary that they will intersect at 90 degrees. So it is not necessary. So line L and line M not necessarily passing through the center. You have line M is tangent to circle 1, to S1, right? What we need is the angle between L and M, right? So the way to do it is basically to think about cosine rule in this figure. So what I will do is I will join C1 and C2, C1 and P, and similarly I will join C2 and P. Okay. So right. So if I want to find out this angle, theta, what I can say is the angle C1PC2, right? Yeah, I have to draw a better figure here. Okay. This is C1 and C2. One tangent line is like this. One tangent line is like this. C1, C2. This is my point P. I am drawing dotted lines C1 to P and also C2 to P, right? And I'm connecting C1 and C2 with a dotted line also. I need the angle between line L and line M, right? So I want to find that angle, and let's call that angle as theta. So that is basically, if you mark this point as T1 and this point as T2, I need angle T1 P T2 is equal to theta, right? Okay. Now think about it. If this much is theta, what is angle C1 P C2? C1 to P and then this, right? C1 P C2 will be the sum of the angles C1 P T2 plus angle T2 P C2. So I'm saying it is this from here till here and then this small angle, right? Right. So now, first of all, what is C1 P T2? PT2, if you think about it, is tangent to circle 1. So therefore, angle C1 PT2 is going to be 90 degrees, right? Because it is the line from the center to the point of tangency. Similarly, you should know that angle C2 PT1 is also 90 degrees. So because angle T2 PT1 is theta, therefore angle C2 PT2 is going to be 90 minus theta, right? Think about what I'm saying. Angle C2 PT2 T1, C2 PT1 will be 90 because PT1 is tangent to the second circle. So that angle is 90. And I already defined T1 PT2 as theta. The angle between the lines PT1 and the line PT2. That angle is theta. So this small angle is 90 minus theta. So the overall angle C1P C2 is coming out to be 90 degree plus 90 degree minus theta. So it is 180 minus theta, right? This is the angle between C1P C2. Now we think of the triangle C1P C2 and we will apply cosine rule in that triangle, right? In triangle C1P C2, I will say what is cos of angle C1P C2. Cos of this angle C1P C2 should be equal to C1P whole square plus C2P whole square minus C1 C2 whole square by 2 C1P into C2P, right? So therefore, cos of 180 minus theta is equal to C1P is radius 1, R1 square plus R2 square minus D square, where D is the distance between the centers, by 2 R1 R2, right? And cos of 180 minus theta is equal to minus cos theta. So therefore, I am getting minus cos theta is equal to R1 square plus R2 square minus D square by 2 R1 R2. And therefore, cos theta is equal to D square minus R1 square minus R2 square by 2 R1 R2, right? This relation gives us the angle of intersection between two circles. Angle of intersection between two circles. And here D stands for the C1, C2 distance between the centers and R1, R2 are the radius of the two circles. Now think about it. This angle of intersection could be 90 degree, right? If cos theta is equal to 0 implies theta is equal to 90 degree. What will be the condition for cos theta to be 0? In that case, we'll have R1 square plus R2 square should be equal to D square, right? So basically we have, this is the condition for orthogonal intersection. Orthogonal intersection of two circles, right? If you have understood the derivation so far, you will get this idea. And now putting it in the circle equation, let's say you have one circle was like this, x square plus y square plus 2g1x plus 2f1y plus c1 is 0. The second circle was x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. The condition for orthogonal intersection was r1 square plus r2 square is equal to d square, right? r1 square is g1 square plus f1 square minus c1. r2 square is g2 square plus f2 square minus c2. And d square is the distance between the center, which will be g1 minus g2 whole square plus f1 minus f2 whole square, right? So notice that on the other side also you're getting g1 square plus g2 square plus f1 square plus f2 square, and you're getting minus 2 g1 g2 minus 2 f1 f2. And this side also you have these terms, so all these four square terms get cancelled, and finally you get the condition 2 g1 g2 plus 2 f1 f2 is equal to c1 plus c2. So this is the condition for orthogonal intersection of two circles, and it is derived from the derivation of angle of intersection between the two circles. Only when you know the angle of intersection can you understand how to get orthogonal intersection, right? Okay. Now we come to the concept of family of circles. So this is very important. So remember this stuff. So if S is equal to 0 and S dash is equal to 0 are two circles intersecting at two distinct points, then the equation S minus S dash is equal to 0 represents the common chord between the two circles. So if the circles are already intersecting, then to find the equation of common chord, you just have to subtract the two equations, as long as you make sure that you subtract the two equations in such a way that the x square and y square terms get cancelled out, right? Now, the second case of this, if the circles are touching and not intersecting, in that case, S minus S dash is equal to 0 will be the equation of common tangent. So common chord and common tangent in these two cases are very easy. Just have to subtract the two circle equations, right? So that is the first thing to remember. The next point is if a circle S, which is S equation is x square plus y square plus 2gx plus 2fy plus c equals 0, and a line L whose equation is Lx plus my plus n is equal to 0. If a circle and a line intersect each other, then the equation of the circle passing through the points of intersection, passing through the points of intersection of S and L will be given by S plus K times L equals 0. So basically, if a line and a circle cut each other, then if I want the equation of another circle passing through these points, P and Q, a third circle's equation passing through P and Q, then the third circle equation could be in the form S plus KL equals 0, where K is a constant. And you can change the value of the constant and you'll get all possible circles that pass through P and Q. There are infinite circles that you can make that pass through P and Q, and all of them will be covered by this standard equation S plus KL equals 0, where K can be a constant that can take different values, right? Okay, now another idea is if you have two circles if two circles S is equal to 0 and S dash is equal to 0 are intersecting each other, then the equation of the circle passing through the point of intersection of the two circles, points of intersection of S and S dash will be given by this equation, lambda S plus mu S dash equals 0, where lambda and mu are constants such that lambda plus mu is not equal to 0. So basically there are two constants now, lambda and mu, and you combine the two circle equations along with these constants, you get a linear combination type of situation. And this is the combined equation of the family of circles or all possible circles that pass through the intersection points. Pass through intersection points of S1 and S2 or S and S dash, right? Why are we writing this condition that lambda plus mu is not equal to 0? Because if lambda plus mu is equal to 0, then you will get lambda is minus mu, and then you will end up with an equation like this, lambda s minus lambda s dash is 0, which will be s minus s dash is 0, which is actually equation of common chord. So in that special case, it will become common chord, right? You don't get a circle equation is lambda plus mu is equal to 0. This we already saw, this was the equation of common chord, right? So these two things you must know what we discussed in the last 5 minutes. These are super important in problems and you need to know it. Okay, now some of the last things in the theory that you need to know is what is a radical axis. So the radical axis is defined like this: locus of a point the powers of which are equal with respect to two given circles is a straight line called the radical axis. Now, what is the meaning that we have just now said? Basically, if you have two given circles, S1 and S2, you can take a point P here and calculate power of point P with respect to S1. Now, if you remember, power of point P with respect to S1 would be PC1 square minus R1 square. Power of point P with respect to S2 would be PC2 square minus R2 square. So we are saying that this is C1, this is C2. If the power of point P with respect to both the circles are equal, so you should have this is equal to this, then P lies on the radical axis. So locus of P such that the power of point P with respect to both the circles are equal. That is the radical axis. And if you recall, we know that power of a point P is equal to length of tangent square from P to the circle, length of tangent square. So basically radical axis is power of point P is also PT square, right? PT1 square. And similarly, you can draw a tangent from here, which is PT2 square. So basically PT1 square is equal to PT2 square, locus of P such that that happens. Basically, radical axis is the point from which you can draw equal tangents to both the given circles. Locus of the points from where equal length tangents can be drawn to both the given circles is going to be your radical axis, right? And the equation of radical axis will come out to be the straight line. So first I will write the result. If you have circle S is equal to 0 and S dash is equal to 0, equation of radical axis is again s minus s dash equals 0. So remember, this was also common tangent equation and common chord equation. And this is also the radical axis equation. So we know that if P x1 y1 is a point on the radical axis, is a point on radical axis. So by definition, the length of tangent from P to this circle would be equal to the length of tangent from P to this circle, right? If the circle equations are x square plus y square plus 2gx, so 2g1x plus 2f1y plus c1 equal to 0. This is my circle 1. And circle 2 is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. So let's get the condition that the length of tangent from this point to both the circles are equal. So PT1 would be the square root of, so it will be square root of this, putting the point in the circle equation. So I will just write it as PT1 square. So I will say PT1 square should be equal to PT2 square if P lies on the radical axis. So therefore I am getting x1 square plus y1 square plus 2g1 x1 plus 2f1 y1 plus c1 is equal to x2 square plus y2 square plus 2g2 x2 plus 2f2 y2 plus c2 equals 0, right? And both these equations are equal, means now I should be able to subtract, right? I need the locus of x1 y1, right? I have made a mistake here. I was putting x1 y1, so I should put not x2 y2. That doesn't make any sense. PT2 square would be what? It will be x1 square plus y1 square plus 2g2 x1 plus 2f2 y1 plus c2, right? And notice that x1 square and y1 square get cancelled, and you're getting 2g1 minus 2g2 x1 plus 2f1 minus 2f2 y1 plus c1 minus c2 equals 0. This is the equation of the locus of the point x1, y1. And basically, it's the same equation you would get if you subtract the two circle equations, right? This is the equation of the radical axis. Notice the slope of the line, slope of radical axis. The slope of radical axis is minus of g1 minus g2 by f1 minus f2, right? And this will become important because the next point is radical axis is always perpendicular, to the line joining the centers. Line joining the centers of the two circles. So if you think about it, one circle center was minus g1 minus f1 and the other center was minus g2 minus f2. What is the slope of the line joining the centers? It will be f2 minus f1 by g2 minus g1, and the slope of the radical axis has come out for us was minus of, if you go to the previous screen, the slope of the radical axis has come out to be minus g1 minus g2 by f1 minus f2, right? So that is clearly perpendicular to the line joining the centers, because slope of the line joining the centers was f2 minus f1 by g2 minus g1. If you multiply that with this, you can easily see that the radical axis is perpendicular to the line joining the centers. The next point to remember is if two circles are intersecting, obviously in that case, common chord is radical axis. Common chord is the radical axis, right? Because the equations are absolutely identical for both. Similarly, if two circles are touching, then the common tangent is the radical axis, right? The next point is if you have three circles, then the radical axis of three circles whose centers are non-collinear, whose centers are non-collinear, taken in pairs, are concurrent. What does this mean? So let's say you have three circles. Let's say the centers of the circles are not on the same line, right? So radical axis of these two circles would be something like this, perpendicular to the line joining here. The radical axis of these two circles will be something like this, perpendicular to the line joining this. And the radical axis of these two circles will be something like this, perpendicular to the line joining this. So this is R3, this is R1, and this is R2. And you can see that the three radical axes will always be concurrent. That is the theorem. The proof of this is simple. You take any three circles, write the equation of the radical axis of two of them, then write the equation of the radical axis of the other pair. Those two radical axes R1 and R2, you can find their intersection point, right? Once you have found the intersection point, you have to show that show that the point lies on R3. The point also lies on R3, which is the radical axis of the other pair that was remaining, right? So that can be proved, and the point of concurrence of these lines is known as the radical center. These are just terms. All you need to do is to use the radical axis idea, which is the difference of two circles. If you take the equations of the circles and subtract them, you get the length of you get the radical axis equations, and from there you can find the point of concurrency, right? Okay. So basically, we have done orthogonal circles, we have done radical axis and angle of intersection of circles, and we also did family of circles. Family of circles when you have a line cutting a circle and when you have multiple circles intersecting each other. Before that, we did common chord, chord with a given middle point, pair of tangents, and that basically is the syllabus that you need to know. There are some other things in that you might find in books like pole and polar, diameters, coaxial system of circles, but all of those things are not in the JEE Advanced syllabus. So right now, since this is a revision class, I don't want to discuss extra stuff which may or may not be in the syllabus. So what we have discussed in the two videos is what you need to know and what is relevant for JEE Advanced and Mains. Beyond that, you don't need to know anything. By the way, we also discussed how to find the equation of common tangents. That is super important, and you should learn the method there. If there is some confusion there, you need to refer to SL Loney book for circles, and there the discussion is there with an example. The theory of circles is more or less done. What we will do next is a few sample problems on circles to revise everything that we have learned, and that will be it for circles. The next topic after that will be straight lines and pair of straight lines, and we will finish off our coordinate with that. I'll try and do it by the end of the week. By Friday, Saturday, I should be able to finish the entire coordinate theory. Next week onwards, we'll be starting a new series, which will be vectors and 3D geometry. We'll do calculus after we finish vectors and 3D. Right? That's it for this video. If you like the content, please subscribe to the channel and share it with your friends. All your support is extremely important to me, and I'd love to see you next time. That's it for now.